I'm so glad to be here, being a member of this community and, sharing this, my journey and my learnings with you in one or the other way. So this is just the very beginning of our interaction, but I'm sure I and you both will gain something out of it. So let's begin. So today's topic is to introduce you to the generation of artificial intelligence, not necessarily generative AI or LLMs, maybe more than that. So the first thing which is in our agenda today is foundation models, how they are different from traditional models, followed by a brief introduction to generative AI, what are its applications, use cases, what kind of models we use in generative AI, how are these models exactly different from the different models and algorithms we have used so far now, what are the challenges in adopting Gen AI in your projects, in your companies. If you do consulting in future in AI, what challenges you might face in terms of applications, what is the future of foundation models, followed by industry level use cases in each industry sector. And then latest, we'll have some Q&As. So I'll begin my, the introduction of AI with a short video, and then I'll give you a brief walkthrough how I made that video.
Welcome to the future where the potential of AI is limitless. Picture this. In healthcare, AI predicting diseases even before symptoms appear, personalizing treatment plans, revolutionizing the way we care for our health. In education, every student has a personalized learning path and a virtual tutor, tailoring education to individual needs and abilities, enhancing academic outcomes. In transportation, AI makes roads safer with autonomous vehicles and smart traffic management, optimizing traffic flow, reducing congestion, and detecting potential accidents. In entertainment, immersive and interactive experiences are created by AI, even a movie that adapts its storyline based on your preferences, enhancing the overall entertainment experience. In business, AI automates tasks and predicts market trends, streamlining operations and providing valuable market insights. For the environment, AI monitors climate change and optimizes resource usage, collecting and analyzing data on climate change, optimizing energy consumption, water usage, and waste management, reducing carbon footprint and promoting sustainability. This is just a glimpse of a future revolutionized by AI, changing the way we live, learn, work, and play. Welcome to the future powered by AI.
So you must all be wondering how we go about making such a video or getting that video without, copyright issues and all, and how to reference the right people when you're using such a video. So this video is totally my creation, but not necessarily I know Photoshop or AutoCloud. I don't know anything of that. I just gave text instructions to ChatGPT, and then there are plugins where you can use references to give credit to people who have contributed, and then it generates the video out of your text instructions. So it's totally AI generated video. I didn't do a single editing here. I just gave the text instructions there. So that is the power of AI. So it's just not entertainment or just not healthcare, just not banking. Not necessarily any kind of business applications. It's your day-to-day lives where you can use these small applications to surprise even your near and dear ones, not necessarily in your workforce, but also in your personal lives. So it's just a reflection of that. Now let's begin our introduction to foundation models. So as the name itself clarifies, foundation models serve as the starting point or foundation to begin a wide range of tasks. Usually in traditional AI, how we used to approach a problem was, say, suppose you have a credit card fraud detection or a different banking use case, then you get the data set, a big data set to train your model upon first. But in foundation models, that thing is overrated. So your model is trained on a certain data set, and it can be scaled or it can be used for a variety of tasks. You need not bring in a very large data set from your custom use case and then train your model from scratch. So they are trained on a very large data set on vast amount of data. So they are large scale models consuming a lot of GPU power and all, but then they can serve on your local as a starting point for a wide range of tasks. So that's the power they bring in, and they save a lot of time for you because you need not start from scratch even in preparing your data. So it's kind of an implementation of transfer learning, but at a larger level. So, like I highlighted, what are the differences between foundation models and traditional models? So, foundation models are large scale models which serve as a base for a wide variety of tasks, whereas traditional models are specific task oriented use cases. So, you cannot translate a banking traditional, AI model to a healthcare model. You will have to get the healthcare data first and then train the model on that data. Vis-a-vis, you can have a foundation model which you can diversify and use for a banking application also, as well as for a healthcare application to do different tasks. You just need small amount of data for foundation models when compared to traditional AI models. Some examples of foundation models are GPT-3, BERT, T5, Roberta. IBM's Granite is the latest one which we have launched. We also have foundation models from our end. Traditional AI models, some examples would be decision tree, support vector machines, linear regression, logistic regression, gradient boost, etc. So, on the whole, we can conclude that foundation models are a little more versatile. They can be more adaptable to a wide range of tasks, whereas traditional AI models are more specialized, user specific, and they require large amount of data. So I'm not saying one is better than another, but they have their different use cases. So now let's begin our journey towards generative AI. So what's the purpose of Gen AI? Why do we use it? So whenever, like as the name indicates, it generates. So it refers to certain documents or refers to certain instructions and generates a new content which does not actually exist until now. So it does not extract, it rather generates. So what are the techniques which power these generative AI models? So they can be powered by generative adversarial networks, or popularly called as GANs, variational autoencoders, popularly called as VAEs, or transformer based architectures. Some applications for these are images, like you saw the video generated, they can create a realistic image, they can merge image. Photoshop or Adobe tools have transformed so much with the add-ons from generative AI, and Delhi is a good example again for image creation. Now, when it comes to artwork creation, painters can use it to publicize their work as well as generate more ideas for their artwork. In minutes, the ideas can be generated and then they can reflect on it. Then, when it comes to text based applications, a popular keyword these days is LLMs. I recently heard a new keyword, LLM ops. So, whenever a new kind of model comes, it's ML ops also comes. So, it's a very big field, lot of applications. The most important application, I think, these days is chatbots. So, any kind of customer service you calls, usually a customer service agent is able to respond quickly to your query, maybe because they are using some or the other kind of chatbot on their end. So they have access to the data by not just reading the data, but by having the chatbot who reads the data and gives them the answers. So it generates human like text, or human like stories. It can even create the script of my presentation. So the use cases are endless with text generation. Now, when it comes to music or audio generation, so there are speakers or musicians you might have enjoyed in the past when you were kids, but they are no more amongst us. But you want to hear new music in their sound, their voices. So this makes it possible for you without you doing additional music editing or composing. You can just give it the instructions and it tinkers the music according to the musician's voice. Now, when it comes to video, the power is that you can create realistic video clips, animated clips, lot of animes for your kids, or you can publicize your work using animes using this, and it's just a few minutes it takes. So there are so many plugins which are available not only in ChatGPT but in so many tools right now which you can use to generate videos. Now, last but not the least, being engineers or being coming from technical backgrounds, we should all know that generative AI has power to generate code or at least assist us in code generation. So it helps in code completion and generation. One of great examples of such tools is Code Whisperer from AWS, Amazon. There's another example here when we talk about is Copilot, GitHub, and we also have Code Assist from IBM. So the applications are endless and they are still revolutionizing, they are still coming up with more use cases, because there are endless programming languages. So there are endless ways they can utilize these technologies. Now let's delve deeper into each of the techniques we use to create generative AI. So the first kind of models we use is generative adversarial networks. I will not presume that you have gone through it somewhere or you have used it. So I will give a brief background what these are. So basically we use two neural networks in a GAN. One of the neural network is a generator and the other neural network is a discriminator. The generator basically tries to produce fake data that resembles the real data presented to it. The discriminator tries to distinguish between the real data and the fake data produced by the generator, and it gives the feedback to generator. So the generator improves its ability to produce that kind of fake data based on feedback obtained from discriminator over time, and it goes on and on. So it becomes so adept at generating data that it's almost indistinguishable what is real data and what is fake data. So GANs have a lot of applications, and some of them are style transfers in documents and images, image to image translation, and many more. They have a very big application and use case for especially able people, because then they can generate text to voice quite clearly. They can generate images to text very clearly, and that helps people to do what, for what they need someone else's assistance or someone else's help to do that. So it enables them to live their life the way they want. The next kind of generative AI models are based on variational autoencoders, VAEs. Now usually whenever we describe something, we describe it as, a black or a white, a yes or a no. But what it does is it doesn't describe it this way. It describes it in a form of a probabilistic structure. So it does the probabilistic structure representation for your latent data. It has two components, encoders and decoders. The encoder maps the input data to a probability distribution in the latent space, whereas the decoder samples from that distribution and reconstructs the data. So basically, there's a training process involved between the encoder and decoder, and a regularization factor, which helps improve the performance of VAEs. Now they have a very big use case in data denoising. So whenever, like in this meeting, maybe it's through Zoom or maybe a meeting through WebEx or a Google Hangout session, you usually have noise a lot. And if you are recording and you want to remove the noise, this might be a good implementation to use. There could be image denoising as well, and it has a great use case in image generation as well. So let's move to the third kind, which is my favorite, transformer based models. So I think if you want to delve deeper into transformers, the best paper to go for is Attention Is All You Need. That's a very famous paper, very basic, and that should be a starter to go for whenever you are starting your journey in any kind of NLP projects. Now, so it uses a self-attention mechanism to train basically. So it focuses different parts of the input data based on its relevance, making it highly effective for sequential data or text. Now, they are typically trained on very large data sets, can be fine-tuned for specific tasks. They have vivid applications. They were initially designed for natural language translation. So they were basically used for translation from English to different languages and vice versa. But they have been adapted to so many tasks. Excellent example for this is GPT-3. So it uses transformers. So now a lot of technology has been spoken about. I know it might be a little bit boring. So let's look at the applications side. So like I mentioned, images. So an artist can create a realistic image from scratch here. If you go to Photoshop and you click on their add-ons there, so there's a very good add-on. If you have half of the image or your image is not that clear, or you don't like one side of it, like many a times it happens, I don't like half of the background, so you can change the image in just one text instruction there. So, and like text to image generation is very powerful, and a good example for it is Delhi. So like if you just go and like usually I always used to look for icons for my presentations or everything. So now I don't go for Google search, I go to Delhi and ChatGPT plugins to get icons for my presentations, so they can generate very use case specific images. Now for text generation, the first application like I mentioned is chatbots, but that's not it. There are so many text generated applications, like you could have summarization, language translation, you could have named entity recognitions. So there are so many use cases for text generation. Like there are languages which have become obsolete or redundant in the past, but they can be revived using text generation, because there might not be authors who write in those languages these days, but these models can write it for you. So we can retain our popular historical languages we have had in the past. Like I remember when I was a kid, I used to read and write in Sanskrit and Punjabi. So like these days I don't hear many people talking about Sanskrit, or so because there are not many relevant large scale authors who sell globally on these, so these text generators can do that. So there are several use cases for text generation in the industry. Now, when you talk about music and audio, one thing is music synthesis. So, and another thing would be voice cloning, modification, sound effect generation. So, like you can have a DJ at your home. So, that can be done just with your laptop and just with small plugins. So, now the fourth thing, which I would say is video completion, video generation from your text, video editing. So, any kind of video task which you want to do, like this video, if you want to combine with all the sessions in this month you're going to have, you can do that and take specific aspects from each session just using a few instructions. And a very big application, and I would say complement to our jobs, is code generation, because usually we waste a lot of time in searching for GitHub issues and Stack Overflow issues. I know none of us know everything, so we go to these issues. So usually there is a plugin for code generation in Visual Studios as well now these days. And whatever language you're coding in, it completes your code, or at least proposes you that this might be the code you want to write, or this is the error in your code. So a lot of time saved from quality assurance, a lot of time saved from going back and forth in black box and white box testing. So it's a very big and grand application. And another use case, it could be like there are so many banking applications which use mainframe, COBOL, which are like redundant, or I would say not many coders exist these days who code in that, because their generation is kind of leading to you know they're kind of retiring. So then we need good coders in mainframe, either to continue those applications, or we need someone who understands that code and translates it to a language which can be understood by coders these days. So it's a very big use case, many giants are after it. Now next is chemical. So why I mentioned chemical here separately, even though it's an extension of text, because the molecular structure itself has a very big use case. Last 3 years, when we were in under lockdown in COVID, there were several companies trying to come up with new vaccine, new compositions. So that can be done with the help of generative AI. So it has a very big use case in healthcare industry as well as life sciences for molecular structure generation and prediction. So that's why I've kept it as a separate category. Now, what are the challenges in adoption of generative AI? What I see forthcoming in the next 5 to 10 years, the first one is, of course, model training and computational cost. So if I am a startup and I want to invest in creating my own foundation model, so it's not necessarily just the data which I would have to generate, but it will also be a lot of computational power required to train on that data for my foundation model to get it. And that requires a lot of money, a lot of time investment, a lot of computational cost. So unless I'm a very big company, or unless I have a lot of financial backing, I cannot create my own foundation model. So either I have to adopt which already has been created and I have to limit my innovation, or I have to find ways to get foundational models through some other, through some other means, like either, getting in alliances with some other company. So that's a very big hindrance for startups, I feel. The second thing would be ethical concerns. Like today I made this video, but I made sure that the credits were given to all the slides or all the pictures which were involved in making that video. But there are applications and tools which are just creating output, but not giving relevant references or references or credits to the authors or the creators. So it steals from those artists. So it's kind of an ethical concern from that side. So it kind of a fake information or fake deliverable. The other thing is misinformation. So we say real news and WhatsApp news, real news and Insta news. So that is primarily because people use these technologies to edit or modify the real time picture, which can, trigger certain events. So that is a very big concern, and there should be a governance mechanism to handle any kind of emerging technology so that it steers in the right direction. The second thing is ensuring fairness and avoiding biases. So long time back, whenever we used to talk about air hostesses, it used to be always hostesses, not host. Like, so now these models web scrape the data, and if they are not given additional input, they would generally learn that its air hostess is a female, so which is not right. And similarly, all power positions were usually historically referred to males, which is not right. So if the data doesn't get additional feedback, then it seems like it would keep on keeping those biases. And when it is used for recruitment or performance acceleration, these biases will creep in for judging the candidates. So that is something which should be kept in check, or the model training should be done mindfully. The fourth thing is ensuring credibility and trustworthiness. So again, everyone is using ChatGPT, but not many know how it has been trained, what kind of data it has used, what powers it. So if it is black and white, it's very good. But if it is a gray box and you do not understand how has it come into picture, how is it using your data, the basically the client might not have that much trust in your implementation. So it's very important to gain trust from your client for your implementation. That's where generative AI researchers would have to work more on. Now, like referencing, I already mentioned, and the last but not the least is engaging content. Many a times people just go to a Medium blog, see how a chatbot is coded, and just code it, but it not necessarily gives you the right answers or the right suggestions. I remember the first ChatGPT version which came. There was a flaw. They were testing it on medical files, and it suggested a psychology patient who came to a psychiatrist that okay, if you don't want to continue with life, no problem, something like that. So, but it has so many long-term implications. So it's very important that relevant, true content is generated and mindfully conveyed to the audience. So now, what are the future of foundation models? So the first thing is, I think the models will become more complex. They would increase more in size so that you do not have to go towards specificity in task. They would be more domain specific. So like you will have a foundation model for finance, for investment. They will have a foundation model for healthcare, so that you do not even have to bring in more data to tweak it to work with your use case. So say suppose I'm working in customer service, I can specifically use a foundation model catered to my product or catered to my industry. The third thing would be there would be centralized committees responsible for ethical AI usage. I think as and when a new technology comes into picture, there should be a governance, there should be a way how we use it. So that it would be an ideal investment wherever a company is going towards AI. The fourth thing would be the efficiency of applications and work in AI would, of course, improve by use of AI. So generative AI would help to improve the improvement of AI in future. The fifth thing would be collaborative AI systems. So when I say about collaborative AI systems, I mean that foundation models will be integrated into systems where they collaborate with humans or other model inputs, leading to some interactive and dynamic AI systems. We are doing this right now in terms of social robotics. Like you have Roomba cleaners at your home, which right now interact with each other. If the sweeper has done their job, they send a signal to the mopper to do their job. But it might be large scale. Say, suppose on the road, you do not have a single vehicle where a person is driving and there are all automated vehicles. So, how a vehicle interacts with another vehicle without giving any signals, and how a vehicle takes an input from a pedestrian would also be a challenge. The sixth thing would be enhanced creativity. So, like with models like Dell E showcasing creative potential of foundation models, we can expect more applications in art, music, design, and other creative fields. Now, when I talk about robustness and security, foundation models become more prevalent, ensuring, they would be more robust towards adversarial attacks, and their security will be more paramount for companies serving those models. So, if a company has one data scientist working on coding an application, I feel there would be two ML ops engineers working on how to ensure the security and governance for the application to keep the application intact and free from any kind of these attacks. Now, regulations and governance. So like IBM, Amazon, Google, every company has their AI governance models as well. So they first test their models on their own governance parameters before productionalizing them. There are guidelines and standards which are established to safely deploy solutions or based on generative AI or foundation models. Now, when I talk about customizable models, I have mentioned that there will be tools or platforms that allow users to customize their own foundation models without GPU power for their specific needs, without requiring any deep expertise in machine learning, AI, anything. And then there would be interdisciplinary integration. So you can integrate your knowledge, your model's knowledge, with other disciplines such as neuroscience, cognitive science, sociology, to create more holistic and informed AI systems. So, like, if I go for my psychiatric appointment, I might face a Gen AI application first so that I don't have to wait in queue if it is an urgent need. And the model is trained enough that it doesn't make mistakes. So, that is also one of the use cases. Now, when we go to industry use cases for healthcare, the big three use cases I have come across right now are: the first is drug discovery and molecular design. Like in COVID times, and even now, we have seen there are chemical molecules designs which are coming up from the power of generative AI. Then the second is personalized treatment recommendations. So there are many a times that every person has different kind of allergies, different kind of psychic status, they kind of have medical history, and many a times there are so many patients per doctor or per nurse that there are things which get ignored. So this can be complemented to the human service which is provided in healthcare sector. The third use case is medical imaging and diagnosis. So an early or preventive diagnosis is very necessary to save life. So generative AI can do that. There are various ways. One thing, it can do data augmentation, it can generate images, and the other thing, it can find ways to diagnose things early on which are not evident in the current technologies in healthcare. So now I move to Gen AI use cases in entertainment. So the first thing which comes to my mind is PS4 and games and rec rooms. So usually they would transform, they would use the power of Gen AI to be more creative. The creations which we see in our movies, we might see in our games. So the second thing would be script writing. So usually you can when you go for 3 hours of movie, you like certain parts but you hate certain parts in a movie. That happens to me a lot, like I don't like violent movies. So usually script writing can be tweaked to the user who's watching it, so you can have a real time movie which is running for 3 hours, but based on your facial expressions and reactions, it will tinker the story and the animated characters. So that's also kind of a future in entertainment. And then music and audio production is something which I already spoke about, so I'll not delve deeper into it. Now, the next industry use case is generally Gen AI use case in business. So the first could be automated content generation. So the content could be text, could be image, could be speech. So right now, I like last week only, ChatGPT released their voice capabilities. They also have browsing capabilities. So different kind of content can be generated which does not exist until now, that can be used for further research or further analysis. So and that might power your next use case, which is predictive modeling and analytics. So say suppose you know the trend of wildfires until now, but you don't know the trend for next year, and you will have to analyze for data for 2 decades or 3 decades to come across what's the trend of wildfires, how they spread, what can be done. But that can be easily handled if you feed the data to Gen AI foundational based models, and then they predict the next decade trend for you and what actions you can take. So the third thing could be customer support and virtual assistants. So I would say there would be a third extension, which would be social robotics, more advancements. So if you visit Wendy's in Toronto these days, you will find a bot there, Bella bot. So it comes, it brings your order, it takes your order, brings your order, and then takes your feedback. So it looks like an animal, but serves very well. So they have capabilities that they can generate data, they can take your feedback, incorporate that feedback, retrain the model, and then they can find your answers again to help you mindfully. There would be some industry use cases in banking. I would say banking is a very big sector in North America and even in Middle East. We would see, and so there are several products which might use generative AI. First could be personalized financial products. So every banking company or even investment company want to sell. So say I am using a particular kind of credit card and I don't want to go for another credit card. Maybe I'm getting so many marketing emails. So those targeted financial products could be sent to my notifications or to my emails if they understand my portfolio really well. And that can be done using Gen AI. So the second could be virtual assistants, like I mentioned earlier, real-time fraud detection. It is really happening now as well without generative AI. You are using MLOps, Kafka for real streaming of data. That happens now as well, but it can be made more efficient if we use foundation models in generative AI instead of using traditional AI models. Fourth thing could be credit scoring. So instead of realizing that my credit score has fallen, you can use generative AI model to predict if you go on spending like that or going with your credit like that, what would be your credit score in next three months, 3 years. So it can help you there. Fifth thing could be propositional of investment strategies. So for wealth management or investment banking, the Gen AI can generate investment strategies tailored to individual risk profiles, market conditions, and financial goals. Now, when we talk about document automation, I have seen several use cases for this one. I think Gen AI can be used to generate any kind of reports. So if you give it like 500 documents, these are the details for my financial reports, for please summarize. So it summarizes each of those financial reports. And then if you like ask it in, like if you code and ask it, I want visualizations for higher level people in my banking sector, they would tinker the visualizations as per that. If you want the visualizations for middle level managers, it will tinker according to that. So it reduces manual effort, it ensures accuracy, and it involves a lot of text generation, document summarization, and it kind of automates entire process for your Power BI, the kind of visualizations you do later on. And now next application would be marketing and customer engagement. So banks usually can use generative AI to generate a personalized customer persona or customer profile, and then use that personalized profile for personalized marketing campaigns, promotional offers, content tailored to individual customers and preferences. And say suppose if someone is like me is quitting a bank, and then they can send me tinkered notifications which could make me stay with the bank. if they understand my persona really well. The last but not the least would be risk management. So by analyzing large amount of data, generative AI can generate predictive models to assess and manage various risks, including credit risk, market risk, operational risk. So these are potential use cases in banking, but there could be more. It's just the introduction. Yeah. So I'm ready and open for questions.